Right now, somewhere more than 15 billion miles from Earth, a spacecraft built nearly half a century ago is still communicating with us. It was designed in an era before smartphones, before the internet became part of everyday life, and before many of the scientists studying its data were even born. Yet Voyager 1 is still out there. Its signal is incredibly weak. Its power supply is steadily declining. Several of its scientific instruments have already been switched off. And every command sent from Earth takes almost a full day to reach the spacecraft. Still, the spacecraft continues to return information from a region of space no human being has ever physically visited. That is what makes Voyager 1 so extraordinary. It was never designed to last this long. When it launched in 1977, nobody expected a 5-year planetary mission to become a decades-long journey into interstellar space. The original plan was relatively simple: visit the outer planets, photograph them, collect measurements, and continue outward. Instead, Voyager became something much bigger. It became humanity's first working scientific outpost between the stars. The story began on September 5, 1977, when Voyager 1 lifted away from Cape Canaveral in Florida. Its destination was Jupiter. From there, it would use the gravity of the giant planet to increase its speed and redirect its trajectory toward Saturn. That gravitational technique was crucial. Rather than carrying enough fuel to accelerate itself all the way through the outer solar system, Voyager could borrow a little energy from the planets themselves. And it worked. In 1979, Voyager 1 reached Jupiter. The images it returned transformed our view of the largest planet in the solar system. Jupiter was not simply a giant ball of gas with a famous red storm. Its atmosphere was filled with turbulence and enormous storms. Its moons revealed active geology, volcanic eruptions, fractured surfaces, and environments nobody had expected to find. Then Voyager continued toward Saturn. In 1980, it reached the ringed planet and revealed another collection of surprises. Saturn's rings were far more complicated than they appeared from Earth. The spacecraft also studied several moons, including Titan, whose thick atmosphere made it one of the most intriguing worlds in the solar system. After Saturn, Voyager 1 had completed the main objectives of its planetary mission. But instead of stopping, it continued outward. And that decision changed the history of exploration. Voyager 1 became the fastest and most distant human-made spacecraft, traveling farther from Earth year after year. The planets were disappearing behind it. The Sun was becoming a distant star. And eventually, Voyager approached something humanity had never directly crossed before. The boundary of the Sun's influence. The Sun constantly releases a stream of charged particles called the solar wind. These particles travel outward through the solar system, creating an enormous region known as the heliosphere. It is not a solid wall. It is a vast bubble-like region shaped by the interaction between the solar wind and the surrounding interstellar environment. Far from the Sun, the solar wind becomes weaker. Eventually, it reaches a region where the pressure of interstellar space becomes strong enough to stop its outward expansion. That boundary is called the heliopause. In 2012, Voyager 1 crossed it. For the first time in history, a human-made spacecraft entered interstellar space. That sentence is easy to read. It is much harder to appreciate. Every human being who has ever lived was born inside the Sun's enormous sphere of influence. Every spacecraft launched before Voyager remained within it. Every planet we had ever explored remained within it. But Voyager crossed the boundary and kept going. It became our first direct scientific messenger from the space between stars. And what it found challenged some of the assumptions scientists had made about that environment. Before Voyager reached interstellar space, Researchers had models describing what they expected the region to look like. They knew interstellar space was extremely thin. They knew it contained plasma, magnetic fields, cosmic rays, and tiny amounts of matter. But from Earth, we could only study that environment indirectly. Voyager changed that. Instead of observing interstellar space from a distance, we finally had an instrument traveling through it. And the environment turned out to be much more complicated than a simple, empty void. One of the most interesting observations came from Voyager's plasma wave instrument. The spacecraft detected persistent plasma oscillations in the surrounding interstellar medium. These signals provided scientists with a way to study the density of the plasma around Voyager, effectively giving us a new kind of sensor for the space between stars. The important point is not that Voyager discovered an unexplained alien signal. It did not. The signal is consistent with natural plasma processes. What makes it remarkable is that the spacecraft is measuring those processes from inside interstellar space itself. For the first time, researchers can monitor the environment surrounding a spacecraft beyond the heliosphere and study how that environment changes over time. And this matters because the boundary around our solar system is not completely isolated from what lies beyond it. The heliosphere interacts with the interstellar medium. Galactic cosmic rays travel inward. Solar particles travel outward. Magnetic fields interact across the boundary. Charged particles can be accelerated, redirected, and filtered by this enormous region surrounding the Sun. That means the space outside the heliosphere can ultimately affect the environment inside it. And that includes Earth. The heliosphere provides some protection from a portion of the high-energy particles that constantly travel through the galaxy. It is not an impenetrable shield, and Earth has its own atmosphere and magnetic field that provide additional protection. But understanding how the heliosphere interacts with interstellar space helps scientists understand the radiation environment surrounding our solar system and how it may change as the Sun moves through different regions of the galaxy. Voyager is giving researchers direct measurements that were impossible to obtain from Earth alone. But then, in 2023, the spacecraft encountered a problem that nearly ended its scientific mission. Voyager 1 was still transmitting a radio signal. But the information inside that signal was no longer making sense. Instead of readable scientific data, engineers were receiving corrupted information. The spacecraft itself had not completely stopped communicating. It was still alive. The problem was that something inside its flight data system was preventing the spacecraft from correctly packaging the information before sending it home. After nearly 5 decades in space, components inside the spacecraft had begun to fail. One particular memory location became a major suspect. The situation was almost impossible by normal engineering standards. If a computer fails on Earth, engineers can open it, replace the damaged component, reconnect the cables, and test it. Voyager 1 was more than 15 billion miles away. Nobody could touch it. Nobody could physically replace anything. The only way to repair the spacecraft was through radio commands traveling across the enormous distance between Earth and Voyager. A signal takes roughly 22 to 23 hours to travel one way. That means engineers could not simply make a change and immediately see what happened. They had to send instructions, wait nearly a day, receive the spacecraft's response, analyze the result, and then decide what to do next. Every step required patience. And every command carried risk. Eventually, engineers found a way to work around the damaged memory. Instead of trying to restore the failed location directly, they reorganized the spacecraft's software and moved critical sections into other available memory. It was essentially remote surgery on a machine built in the 1970s, operating billions of miles away with a communication delay of almost 2 days for a complete exchange. And it worked. Voyager began returning usable scientific information again. The spacecraft had survived another crisis. But its greatest challenge was not a software failure. It was power. Voyager 1 gets its electricity from radioisotope thermoelectric generators, or RTGs.